in this module, we're looking at some of our visibility tools, and we'll first look at an example of the Viewshed tool. So in the lab for this week, you'll be looking at a historic communication network. In our demo that we're going to see here, we're looking at a more modern version of a communication network. Specifically, I'm going to show you an example of the Coachella Valley Regional Earthquake Warning System. During its development, this system was providing earthquake, the idea behind these systems are that we're getting early warning services to emergency dispatch centers, fire stations, hospitals, schools, healthcare facilities, that these systems are quickly transmitting warnings of dangerous earthquakes before the shaking starts so people can take cover or prepare for the earthquake. A quick review of earthquake warning systems. They are detecting the non-destructive primary waves, or P waves, that travel quickly through the Earth's crust in advance of the more destructive secondary waves. So that delay between the P waves and the S waves gives us that early warning system, to put it very simply. So why Viewshed? Why are we using a visibility tool here? Well, a real-time earthquake warning system requires that comprehensive line-of-sight, reliable communication network. We need a communication system that links the ground motion sensors, the data processing hubs, critical facilities, etc., to detect that earth movement, filter out, just a big truck going by, and quickly warn those impacted facilities before those S waves, before those secondary waves arrive. So in the Coachella Regional Valley Earthquake Warning System, there are several cruise points that you're seeing here, fire stations, schools, and then just general sensors. Most of them lie within, Palm Springs and Indio, Palm Desert, all of these municipalities. They are supported by a high-performance wireless research and education network that's partly put together by UCSD Supercomputer Center that gives internet-connected cyber infrastructure and supporting wireless data networks in areas that are not typically served by other data networks. So we have, what we're basically doing is we're looking at the Coachella Valley regional area and trying to determine where we are going to put a tower to help support this early warning system. So this is, from 2013, 2016 type questions. And we're going to look specifically at the high point here, Toro Peak. So Toro Peak is the highest point in the Santa Rosa mountains. So the idea being that if we're at the highest point, if we're looking north, east, northwest, we are going to be able to, quote unquote, see all of our cruise points and therefore be able to quickly transmit information and early warnings to these areas. So that's that line of sight Viewshed. This would be our major communications hub, and it would easily be able to distribute and quickly distribute that information out. So that's a long introduction to this lab, but I think it's important to kind of walk through why we are doing this Viewshed module for our modern communication. So just like in the lab, we'll be looking at, can you see something? Can you see, smoke rising? Here we're looking at, would this work for our rapid warning system? One of the nice things about Viewshed analysis is that it can be straightforward. I should say it is pretty straightforward. One confusing thing is there are two Viewshed tools. In the lab, we'll be working with the original Viewshed tool. In this example, I'm going to show you Viewshed 2. One of the reasons we're using Viewshed 2 is if we open the attribute table for our points, for our cruise points, our warning system points, all we have are the site names, the latitude and longitude, and the sensor type. We don't have any information about how tall these facilities are, or how far off the ground they would be. So if that was built into the attribute table, or if we built it into the attribute table, we could use Viewshed 1 or just plain Viewshed as effectively. But since we don't, we are going to use our Viewshed 2 tool, where we can have a little bit more control over our observer inputs and Viewshed parameters. The first thing you'll do is select your input raster, which for us is our topographic layer. And it's telling me it doesn't have a vertical coordinate system, it has heights reference to a spheroid. Let's quickly fix that. Let's make sure that you know what we'll do? We'll set it in the environments. We'll make sure we set our vertical coordinate system. Actually, let's put it back onto the other one. Okay, just the plain one. Okay, so we'll set that there. I also set some parameters for cell size that would be the same size as the 30-meter topo data. It's the input point or polyline observer features. So in this case, our observer features are that communication hub that we want to put in at Toro Peak. So we'll select Toro Peak. And our output raster, the Esri example has you create a pretty specific output raster that's telling you which Viewshed tool you're using. So VS02. And we are going to set the antenna at 21 feet and the observer antenna is at 5 feet from the ground. Okay, so then we go into our Viewshed parameters. Nope, we're going to go into our observer parameter. We are going to change two things. First, we're changing the surface offset to 5 meters. That's what we're changing. All of the antenna for our cruise stations, they will take the elevation and add 5 meters on to be the top of that antenna. The next field we will change is our observer offset, and we'll change that to 20 meters. So this will add 20 meters, a 20-meter antenna to the top of Toro Peak. There's already a offset of 1 meter. That's what I'm thinking they add in the 1 there. That's weird. Anyway, so we're going to keep it at 20 meters. We're saying it's 20 meters above. And from there, everything else will stay the same, but here's where you could change things like the horizontal angle, like how high or low you could change your head, etc. So we'll go ahead and click Run. So we can see that orange default output. This Esri exercise does give you some layer files so you can quickly change the symbology, which I'm just going to grab really quickly. And change it to this nice navy blue, and then they want you to change the transparency so you can see what's under it. Why is it doing that? And there we go. So from here, we can see the stations that are covered and the ones that are outside of the Viewshed. So you can zoom in and out. You can see here we're missing this one, this high school. A couple high schools seem to be outside, just outside of the Viewshed. And even looking, at southwest, you can see that the proposed station would be included. So from here, we could go on and select out how many stations are covered, how many stations are not covered, and then what that means for maybe the height of the antenna on Toro Peak, or maybe this wouldn't be the best location for our repeater tower.